Hey, how's it going? We're back. So before we get back to building the robot, um, I'm still kind of noodling on the intake. I wanted to get uh, an introduction for you on actually working and creating solids. Because up to this point we've been dragging and dropping and very little and maybe a little modification of existing parts. What we're going to do now is actually create something from scratch, create a solid body from scratch. And what we're going to do, you'll see here we've got the 2023 robot Petrichor on the screen. And one thing that I can't remember if it was another mentor or student or what it came up with or how it came about. Somebody had said, what if we had a tool to spin this motor by hand? So for those of you who don't know, this is a Neo motor, and this is what's called a climber in a box, but we're just basically using it on the robot as an extension arm. So these blue pieces extend by a spring force. And what is this is a small motor that has a winch. You can kind of see the barrel of the winch right there. And what that does is it winches it back. Well, the problem we had was if at the end of the match, if the arm was extended or if we dropped power on the robot, those things, those extension arms, automatically extended out, and they went out about 18 inches, or they could go out. And this motor, these things right here, these little sandwiched pieces, those are gearbox additions. So each stage was a 5-to-1 gearbox. So in short, what happened was the arm would extend and we would spend 10 minutes rotating this by hand. Each full rotation was maybe 1/8 of an inch. So we said, what would happen if we could sketch up and build an adapter that would fit on the end of this motor? This whole cylinder rotates. What if we could just take a drill and just zip it down by hand? So off camera, I went ahead and did that. So basically what we've got here is a hex shaft and then a cone that fits down into the motor. So I brought in a motor, and I'll go over this in the video. But what you can see here is this thing. Let me change the visibility so it's a little bit easier to see. You can see this little tool or bit encompasses the end of the motor. So we can just take a drill and rotate the end of that motor by hand. And you can see here, sure, I've already printed one out, and we're going to try it tomorrow at practice. So we'll see how it works. So what we'll get going here in a minute is I'll walk you through how we went about developing this tool. Okay, so we're starting with a fresh project. So before we go ahead and insert any parts, we have to save it. For some reason, Fusion does not let you save it. So Neo adapter, we'll just give it a name, and then we'll just call it new because I think I got one. Yeah. Okay, so we've started our new part, and then you can see over here, I've already gone and downloaded the model for the motor from Rev's website. So we're going to go ahead and drag that in. It doesn't matter what orientation. I prefer working from the top down. So we're just going to drag it until it's facing up. Okay, so now we've got our motor in the orientation. Now I'm going to go ahead and create a cylinder. So underneath the create command is you got a whole bunch of what Fusion calls primitives. Box, cylinder, sphere. We're going to go ahead and create a cylinder. And again, much like a sketch, you have to pick a plane where you want to place that cylinder. So we're going to put it right on the end of that motor. Okay, so we've selected the face. Now what's cool is it'll transfer, it sees that this is already a circle, so I can go ahead and pick the center of that pre-existing circle as my base point. Now it says, how big do you want it? Well, I don't know exactly how big the, or what the diameter of that motor is, so I'm gonna come over here to the top. And this doesn't have to be precise. And I am going to pick a distance just a little bit bigger than the motor itself. Again, it doesn't have to be perfect. So now we're looking from the top of the motor down. We want to go back to our main view. Now what I'm going to do is I am going to do a, I'm going to pull this down into the motor. Okay. And what that does is it's going to interfere with the motor. It's not a big deal right now, but eventually what I'm going to do is I'm going to cut this motor, the contents of this, from here. So it's basically subtracting the motor from this cylinder that I'm creating. So you can see here it's creating a new body, and then we'll click on OK. All right, the next thing I'm going to do is I'm going to create another cylinder on that one I just created. So right there. And we're going to make it the same diameter. We're going to come up, we'll call it 10 millimeters. The key thing we got to remember here now is, I guess, yeah, we can go ahead and join it. Okay, so now we have the part we're going to subtract the contents of this motor from. Now, if you remember, in one of the prior videos, I had said bodies or components don't have bodies, or I might have said something like that. Well, believe it or not, there are bodies in this motor. You can see it right there. Okay. So now what we're going to do is we're going to do what's called a combine. Now, when you say combine, why would I want to merge these two? Well, the way Fusion works, this is what's called a Boolean operation. So you can either join two parts, you can subtract two parts, one part from another, or you can do what's called an intersection. I've never used the intersection. I've always used the join, the actual joining, or the subtraction. So here, we have to select our target body. I'm going to start from scratch. So I'm going to go modify, combine. So now my target body, that's the one I want to do the modification to. And in this case, it's this cylinder we just created, right? So we'll select that. Now my tool, think of it like a cutting tool. I want to be able to select this motor, but if I go through, if I just go ahead and try and pick the motor, it's not going to let me, because in this case right here, it's in there as a component. But if I go down and select the body that's in that component, it will allow me to do this operation. Now here's where we select the operation. Do I want to join the two together? No. But I want to cut. Okay? You can see that it goes red now. Now what I've got is, that means that everything that's in red is going to get subtracted from the blue body. So if I click on OK, doesn't look like we did a whole lot, right? Well, let's turn off the motor and see what happened. And then we'll look at it from the back side. Now, it's no longer a boring cylinder. It's got all the details from the end of that motor that we're trying to interface with. So then what we can do now is we can go ahead, if we were to take this model right now and print and try and 3D print it, it obviously wouldn't work. We've got this bar coming across, we've got these nubs coming in, and even if we didn't have those, the print tolerances in most printers isn't good enough, and we'd never get the part to fit. So now what we have to do is go ahead and clean up this surface, make it printable, and also make it so that once we do end up printing it, it should fit a lot better. So the first thing, now that we've made this, it's got a bunch of faces on it, right? We can go ahead and Fusion lets you just blow away faces. So I'm gonna select that cylinder that's in the middle there, and I'm gonna click on it, and I'm gonna hit the delete key. So I'm gonna go through there and delete all these little nubs and clean it up a little bit. So we can delete that, delete, 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 delete. I'm also going to delete this little guy. Let's see if what happens. No, that's not what we wanted. So I'm going to hit the undo button. Controls, it's up here. Or I like hotkeys, Control Z. So I'm going to hit Control Z on that. Let's see if we can do a better job. There we go. Okay, so now that we've done all that, we need to go ahead and start giving ourselves a little bit of room for error and some cushion when we go to print this. And to do that, we're going to press pull all these surfaces, and what that'll do is it'll basically expand the inside of this to give us a little bit better shot of it fitting right when we print it. So I'm going to hit this press pull command, and what I'm going to do is I'm going to select all these faces inside, and it can be a little finicky, so we'll hope this works. But all these faces that would interface with the motor itself. All right, just one here. And there's two. All right, so we'll see what happens with this. So I'm gonna go negative because I want to grow that surface out. So minus 0.35. Okay, that one worked. All right, so then we'll just hit enter. So basically what that's doing is it's pushing all that surface out 0.35 mils. That's pretty good, a pretty good setup for a printer. Some printers you can get them down to 1/10 of a mil tolerance, but for our sakes, this isn't a precision part, so 0.35 should work. Okay, so you can see now that we've got this part. It should fit okay with the motor. Let's double check, and we threw that motor in there. I see one more surface that I probably want to give a little more tolerance, and that's this inside of this cone. So let's turn this motor back off again, and we'll press pull this a little bit, another minus 0.35, and then let's check our work again. Okay, so now we've got, you can see there's a little bit of a gap right there. Should be pretty good there. So I'm going to save my work. And now we're going to work on the top side. Okay, so you can see, I'm going to select this motor. Now this is probably a little bit overkill in terms of how deep this cylinder is. So I'm going to come back and press pull this again. And I'm going to bring it down a little bit more. Probably 5 mils. And let's see what that looks like now. Yeah, that's probably pretty good. Okay, so now we've got the part that interfaces with the motor, but what about the part that interfaces with our drill? Now, there are two options you could probably do it. The first option, the way I made this one, is I put about a 3/8 hex on the end of this. Now the risk for that is, and go this screen, the risk for that is if you look at this part, this is where all the layer lines, it was printed going this way. And the problem is the layer lines are the weakest part of the print. If we were to apply any sort of torque to this, and we'll find out tomorrow, but I'm thinking this might just snap off right off the bat. The way around that is if you can use a socket adapter that would go into your drill bit, and basically what it is, it's hex. It's a steel bit. It's hex on one side and square on the other. You can just put any standard socket. So I think we're going to do that with this one. So I'm going to try and do that right now. Okay, so what we'll do, first thing we're going to do is create a sketch on here on the top of this. Okay, so now what I want to do, I've created a sketch on the top of this cylinder, and I am going to create a rectangle. Now there are a couple different ways you can do a rectangle. I'm going to use a center point because I want it directly in the center of my cylinder. So here, drag it out, and then I want to do it a we'll do 1/2 inch. We'll do a 1/2 inch drive. So 12.5, and then actually we'll give it a little bit more. We'll give it a 13 mils and then 13 mils. Okay, so I've got my sketch. That's really the only part that I need. Okay, so then what we're going to do, we're going to extrude that outer part. You can see here I clicked outside here, and what that'll do is it'll only extrude this outer island. Now I can go ahead and click inside, and it'll basically just extrude a whole surface. We don't want that. I just want the outside part. I'm going to go ahead and extrude that. We'll give it a full 1/2 inch, so 12.5 mils. And then we'll click, see I put 12.5, hit enter. Now the other thing that I wanted to do, I want to taper this thing. This thing is probably a little overkill. We probably don't need all this plastic on the part. So I'm going to do what's called a taper. And this can be a little finicky as well. In Fusion, it's called a draft. So we'll click on the draft. Now the first question, or first information it wants is the pull direction. Now, it took me a while to learn this, but the pull direction basically is gonna end up being, you select the face that you want it to be at the widest point. So in this case, because I want it to kind of cylinder or cone up, that I want this to be the pull direction. So then the next thing you want is the faces. You select that, and you can see how it changes into an angle. So I can go ahead and tweak that, make it more cone shaped. Okay. So this is essentially done. The next thing I want to do, I'm going to add what's called a fillet, or I'm going to add a little radius to this to make it easier to install my my socket adapter. So I just typed F for fillet. I'm going to select that surface and give it a 1/2 mil. Give it 1 full mil. Okay. And that is that. So now we have developed one little tool. If you wanted to save a little bit more filament, we could probably shorten this surface up a little bit as well. There. And that's our adapter. Okay. So that's our first real foray into creating solid bodies from scratch. So the next video, we're going to get back to the robot.